Good morning, guys. Good morning. Good morning. Yeah, so let us start the session. Okay. So I'll take the question one by one. And if you want to unmute and speak, let me know. Okay. Great. So let me just open the code also. Yeah, so I have opened code. Let me just share my screen. Yes. So let me see what question. So Sumit has asked the first question. The question is related to figure UG 29.1. So he's asking what will be the length of gap in unsupported shell? But in unsupported shell, how you will, what do you mean by unsupported shell? See, if you are having, see, UG 29 is for supporting when you are providing stiffening ring. Okay, I'll just open the figure also so that you guys can see. This is UG 29. We are talking about this figure, right? So you're talking about the support as a stiffening ring, or you're talking about the support which is the saddle support? Okay, let me see. Sumit is there. Sumit is there. Sumit, you want to unmute and speak?
Hello, good morning, sir.
Yeah, good morning.
Sir, this second figure in right,
Mm-hmm.
there is gap in ring for drainage.
Correct.
Right now, I'm designing one tank which have 12 compartments,
Mm-hmm.
and there are 12 baffles for means dividing two compartments. The
Correct.
baffles are 10% means less than ID.
Mm-hmm.
So my question is whether we need to provide external stiffeners or whether code allow us to eliminate the external
Why you
stiffener.
are getting confused with baffles and support ring? Are these the baffles?
No, sir. But we can use the baffle as a internal stiffener also, no?
No, you cannot use baffles as an internal support ring. See, baffles are not attached. Okay, they are always will have a difference of diameter. So
No,
how
sir.
it will
No,
be
no.
able to support?
So the baffle means by baffle I'm not talking about heat exchangers.
Acha,
This is simple tank. The baffles are welded inside the
acha, yeah,
circumference
it
of
is
the.
welded. So that is,
Yes.
see, now you can consider that as a stiffening if it's already welded. For flow purpose or for process purpose, it may be a baffle, but for you, it is a stiffening ring.
Yes.
Yeah, so you have to call it stiffening ring, not baffle. Okay, so now there is a stiffening ring. So definitely there is no diameter difference. Now, if you are already welded.
Yes, sir. But only thing is the top side of the baffle, no, there is
Mhm.
a gap. I mean 10% of gap. My ID is
Okay.
4000 ID of the vessel.
So there is
And
a
at the
gap like this, what is indicated here. Some
yes,
gap
but
is
at
there.
the top,
Does not matter. Just
yes.
stop it. It can be anywhere.
Yes, sir. My question is whether we can use it as an internal stiffener, and if yes, then how much arc we can assume?
Okay. So first of all, like I said, it's not a baffle, it's a stiffening ring because you're
Yes,
using
yes,
it as in design as a stiffening ring. So definitely you can use. Second question related to how much gap you can have. This is what is indicated here. The gap in the ring, it's not only for this. Here we are using it for draining purpose, but you can have this gap, length of any gap okay, shall be as per 29.2. If you see this, so you have to find out L by D ratio, L by D naught ratio, and D naught by T ratio, and see which arc it is intersecting. Based on that, like, let us see if it's touching this arc. So based on that, 0.065 into D naught. This is the value of your arc, which can be without support. Like, it can be, that much gap you can have. Is it making sense, Sumit? Is it what you asked, or Sumit, you're there?
Yes, sir.
Yeah.
Sir, mm, can you go to the this arc, that figure?
Yes.
So L means 10 to 10 line, right? Design
L does
length.
not mean, L is unsupported length. For external pressure, it is unsupported. See, L is properly defined for external pressure. So this is your L. Okay. This will be like, if you have multiple stiffeners, then how much shell length, which load that stiffener is taking. That is your L.
Okay.
Okay. So if you may be having, see, if only one stiffener is there, then your complete the tan to tan length plus that h by 3 of the addition, the total thing becomes the part of L. So just divide by 2, that will become your, if you see this figure, okay. So this is my L for vessel, which is not, there is not a single stiffening ring. Okay. Now, if I'm providing a stiffening ring, let us say here, or let us say in this vessel itself, if I'm providing a stiffening ring, to say stiffening ring like this, then my L will be from here to here, and the other L will be from here to here. Making sense?
Yes. Okay.
Okay. So that will be your maximum gap which you can have based on this 29.2. Okay, now it's clear?
Yes, sir.
Great. Okay, so Lagaman is asking, if the vessel is in vertical, then the drainage gap shall not be provided, right? See, if it's not there, then it's not there. There is this is exemption given when you have to provide, right? All other places will not like to have this gap. We typically weld a ring which is circular and welded all together. But now let us see for drainage. If we don't provide this gap, then there will be accumulation of fluid. Okay. So we need to have this gap. So how to provide? So that is the provision given by code, that you can have this much unsupported also. So it will act as a gap. No, you can even have more gap than that. More gap than 29.2, but only that location where you have some support, like saddle is there. There you can have even more gap. The saddle cross section, which is given by C, should be able to compensate the moment of inertia. It should have greater or equal moment of inertia than the ring. Okay. Then it is, even having more gap is also acceptable. Making sense? Lagamanna and Sumit?
Yes, sir.
Okay, great. So, okay, the next question is about again Sumit. Uh, it's related to 44B. Okay, and Sumit is asking, is derating compulsory for nozzles for use stamp jobs? Okay, so where that derating is given, Sumit?
UG 44B.
Right. Let us try to study 44B if we are getting some clues. See, if there is like maybe or something like that written, then it means that it is an optional. If there is no maybe or then it's a kind of compulsory thing. So if I read here 44B, external loads may be evaluated. Okay, may be evaluated for flange joint with welding neck flanges, according with this fundamental. Okay, this formula which we use for providing the derating. So this is one of the option. Now let us see if I have derated. Okay, I have performed this calculation and my flange is not getting qualified. Okay, while I'm derating, I need to, it's indicating that I have to change the rating. Then what I'll have to do? What I'll have to do if this, with this, if I need to increase the derating, that is what it is coming. Then guys, come on. It's for everyone. You can answer in the chat. If you want to speak, we can unmute you. Okay, let us first coming flange rating can be increased. Okay, that is the one option. Now, if I don't want to increase the flange rating, then
Can
do I
we
have
work
any
on
other option?
FE analysis to qualify the
Okay,
loads?
Sumit is saying FE analysis. We'll come back to that. Stiffener for flange. We're talking about flange derating, Amol. How stiffener will be, we don't provide stiffeners for flange. RF pad, increase thickness. What is the question? Okay, change the size. Okay, again, I'm repeating the question which Sumit has asked. So first part of that question is derating compulsory for nozzles for use stamp job? Okay, so first we are talking about, let us see, if we read this statement, what it says, may be evaluated. That means it is one of the way. Okay, so it may be used, may not be used, because if code is saying shall be evaluated, that means we have to compulsory follow. Okay, but now let us stick to the first question, that whether it is compulsory or not. Okay, now let us see, you estimated this, that no, I don't want to derate. No, I don't want to use this 44B for derating. Whether that will mean that you don't have to do or you have to do by any other way. Can I ignore derating? Maybe in any other way. That is what Abhishek is asking. What about others? Come on, guys, please respond here. See, I consider that everybody has gone through that. Whatever you feel, it's not only for the people who has asked question. I know that it will be a problem for most of you. Okay, so when we are discussing, the purpose itself is to discuss. Otherwise, we can just simply write the response based on the queries. So the question is whether we derating whether is required or not. Okay, first of all, why derating is required? Let us start with that. Why we have to derate, first of all? when the derating requirements comes into picture? Come on, respond to that. Why we need to derate? Why we need to derate the flange? Come on, I need response from all of you, yeah. There's that much you can do. So Uddhav is saying, Abhishek is saying, consider forces and moments to check flange can sustain load, process nozzles, to take care of external loads. External loads, right? See, process nozzle may not have all the time external loads. Okay? External load, if it is mentioned, okay, in our data sheet that for these nozzles, we need to consider external loads. You can see that clause starts with external load. Okay. So if there are external loads coming on that nozzle, okay, this is also very interesting part. People always try to misunderstand this, that what will happen. Let me just elaborate a little bit. This is my shell, and I have a nozzle connected to it, and there is flange connected. Okay. Okay, so this is my configuration. Okay, so now if there are external loads coming on this nozzle, let us see, we have a piping radial load, which is getting exerted on this. Okay, this load is acting. As a designer, what all calculation you need to do? There is a pressure vessel, nozzle. I know you'll be doing internal, external pressure, all that. Okay, that is already done. There is external load coming, which is this, on that nozzle. It is coming because of piping connected to that. Okay, this load value is given. So what all calculation you need to perform in this scenario? I'm saying balancing forces and moments. WRC calculation, Ajay and Akash. What about others? So when I say all, you have to mention all the things which you have to do in this case. Okay, believe me, it's not that simple. Udayji is saying shell buckling. Uday is saying, can you unmute? Let us first respond, and then I will unmute Uday. Okay, let others will also respond. WRC calculation, WRC calculation. Okay, now let us try to see with normal. See, we are not learning just to solve this problem, but actually how we think. Okay, my intention is always to assist you in thinking process. So let us say Abhishek's answer we are taking, balancing forces and moments. Have you anywhere in the code seen, Abhishek, that how to do balancing of forces and moments? See, balancing, if it is supported, definitely the support will be taking care of that additional load. Okay. See, okay, one thing is code, but code also says that if it is not given in code, that does not mean that you don't have to design as per that load. Okay, if load is there, you have to design as per that. Okay, again, we'll come back to that of how what exactly we'll be doing in balancing and balancing of moment and forces, that also we'll see. Because of that also there'll be additional calculation which will be required. Okay. Now I'll just unmute Uday and see what he has to say. Let's keep on thinking. It's not like, just a simple question which it answers most of the queries related to this. Okay. So it's kind of subject which we are trying to study here, not just a single question. Uday, now you can unmute.
Sir, code actually says to consider these external loads.
Mm-hmm.
So it is not saying that we have to perform WRC or any other method.
Mm-hmm.
It's saying to consider this
Consider
load.
this load. Correct.
So from the engineering practices, we perform the WRC if it's in the allowable limits of WRC. If
Hmm.
it's not, then we go for the FEA.
FEA. Okay.
This is for the nozzle to shell tension.
Correct.
Stresses the nozzle as well as on the shell.
Hmm.
And for the flange, we perform the derating.
Correct. Okay. That second calculation.
Yes, sir, second.
And next, that's it, or anything else?
And sir, these loads also considered in the supports design.
Correct. So that is the third
Third point.
calculations which will be there. Okay. Anything else?
Mm, so this is, I think this is the only 3 times.
Okay. Uh, so I hope all of you also listened. So now we have got 3 different calculations. Okay. And that is not all. Again, built on that. Okay. So see, the thinking should be very simple. Okay. And you have to always think with the typical engineering judgment, typical, or you can say, whatever we have learned in basics. Okay. Let us see. This is a skirt which is there, or it may be leg support, whatever it may be. Okay. Let us say this is there. Okay. Now, so what first? See, because of this load, where that stresses will be getting generated, will have stresses. Okay, let me just use this. We'll have stresses in this portion. Do you agree with that? The junction of shell to nozzle. There will be some additional stresses. Just visualize. Okay. Okay, Akash, we'll come that to anchor bolt also. Don't jump. What we're talking about, that first stress, which will be which is very critical for us to evaluate this junction. Right? Everybody agrees to that. So for that, I'm trying to very simplify, but you it will be learning for, I think, almost all of you. Okay. It looks very simple, but it becomes complicated when you try to use it. But where we do mistake, that also will tell. Okay. So now this is the junction which we are worried. Okay. That is the first calculation which we need to perform. How we can do that? How we can find the stresses at this point? WRC, WRC, right? So everybody knows that. Now let us say this load which is given to me. Let us see, we have three, all the 3 load. I've indicated only one, but you can consider there are all the 3 directions load: circumferential, longitudinal, and radial. All the loads and moments, the 6 load which we typically see, all are there. Okay. But that is given at the flange face. The loads are given at flange face. Okay. Now, can I use that load as it is for WRC? Abhishek is saying no. Lagamanna, no. No. What about others? I hope you have understood the question. That nozzle load, which is given, that is given at the flange face. Okay. Can I use the same load in WRC? When I say WRC calculation, how we do that? We open the WRC section in the PV Lite and fill the data. So I'm simply saying whether whatever values are given here, I can use that to fill that data for WRC calculation. There is a mixed response. Okay. So Jagdish and Abhishek, if you are saying no, Laga Manna, why no? Why I cannot use? Why I cannot use the same load which is given at the flange face for WRC calculation? Why you are saying no? Flange and nozzle junction will also have some effect. PV Lite has both the options. Okay. At junction or face. Okay. Come on, guys. WRC calculation when we are doing. In WRC, the nozzle loads are considered at which place? Guys, see how that becomes interesting. I'm not sure, just judging. Okay, don't judge it. Just try to. I think you guys have attended the WRC calculation, which we did in WRC at junction, at shell to nozzle junction. Okay. See, the WRC calculation has been performed. So definitely the nozzle load will be considered at some point, right? And it cannot be nozzle face because it does not talk about the length part of it. It considers load at only the junction. So whatever load which we are using here, that's need to be converted to this point. Okay, now let us try to open PV Lite and try to see what option is there. Okay, and then it will complete. So still we are talking about only the first part. Okay, I'll come back with the second part, which is derating, and also to the third part, which is saddle support. What will be the effect here at the anchorage, or the skirt. The fourth part, which Uday also missed, is the nozzle neck. There will be additional stresses coming at the nozzle neck also. That also need to qualify. That is the fourth. So 4 calculations, only because of this nozzle loading. So now we are at first point. Let us try to understand this in detail. Let us open PV Lite, okay, and see. Sorry. So we started with derating and Sumit might be thinking that I have forgotten your question, but not. We'll come back to that also, but let us start with some basics also, that we are very clear that what we need, because these are the things which you have to do all the time. Typically, okay, your vessel will have nozzle loading. Okay, and when you are designing USTAM, you have to be pretty clear with what software is doing, what software is not doing. Okay, so you have to be very careful with that. Now let us take any one model. This is the absorber model Now let us see, there is a nozzle here on the top. Okay. Or let us take a different model. Otherwise, there is no nozzles at the shell. So let us take one master. Okay. Let us take that amine regeneration, which we have done in the class itself. So we'll go to training marathon. Okay, let us take this. Now, let us take any nozzle. Okay, we'll go to this tab, local stress analysis 107 and 297. Okay. Now, if it is on shell, which option I'll take? If I'm analyzing a radial nozzle on shell, 297, no doubt in that, right? So I'll select 297. Okay. Now, there are, for if I'm selecting 297, only one sustained option is there. Okay. Now, this is the where we'll be putting all the values. Okay. Right. This is the location where I need to input the data. Okay. So the data means the 6 loads which we have got as an input. Okay. Now, if I want to indicate this at the nozzle face, can I do? So Uday, you can respond to that. How we can give this value at nozzle face? Which option you will select?
So these are the values of the French.
Sorry?
These are the values they have given as a French.
Sorry, I didn't get again.
If I'm giving the inputs, so these inputs will be considered by the PID the forces and movement at the flange face.
At the flange face?
Yes.
Why do you conclude like that? Because if we are performing WRC, okay, and in WRC the loads are taken at the center.
So actually, once I have seen the option that there is given design constraint or load is somewhere, where we have to put the tick some point
Some
to
point.
some point is given that you want to consider the loads at the junction. When we tick that point, then the software understands that you are giving a load at the junction.
Yes. See, basically you have to be very clear that where you are putting that load. That we are very sure. Now let us see if in this options there is anything like that. In load case, you are saying something is there.
In load case or example that
Nozzle loads applied at the
yes,
end of nozzle. Okay. So basically this option is there, which you can use if it is at the end of nozzle. But if you are not using this, then what you can do, you can recalculate all the loads at the center line. Okay. Getting it, guys? So either you can use that option or you can convert. You can bring all the loads, you can transfer. You can just keep yourself muted. Where's muted? Who is that? SM. Yeah. Sorry. Now I hope it's clear. Yeah. So what I'm saying, whatever loads, 6 loads are given, if you are directly inputting here without selecting that option, then it will be taken as center line. Okay. The nozzle to shell center line. Okay. So if I have a load which is not given at center line, okay, then I have to transfer these all the loads to this location at the center. How I can do that? Anybody? How I can transfer, this load given at this location to this location? So let us talk about the first load, radial load. Yeah, that is absolutely right. So for radial load, any change will be there if I apply no change, right? Because it is not creating any moment from this point to this point. It is in the same line. So there is no moment change. Okay. Now let us talk about VL. If I'm transferring this to this, what I need to do? Okay, Akash is asking which force. We are jumping to different things. Are you clear with this, Akash? If yes, then please respond to this. Okay, then reply. Okay, let Akash answer. Akash, tell me, if VL we are transferring from face to center, what will be the method? Akash, I'll try to unmute you if you want to speak.
Yes, sir.
Yeah, Akash. So how I'll
What was
transfer
your
this?
question, sir?
Okay. Yeah, that is the problem which happens, if you are, thinking something else, doing something else, and are not fully where you should be. Okay. So again, I'll repeat the question. This is my longitudinal load. Okay. I'm transferring it from face to the center line.
Yes,
Why I'm doing that?
because we have to evaluate for across nozzle to shell junction.
We have to calculate WRC, and WRC considers the loads at the junction of the
Yes,
nozzle to cell. So what will be the methodology? How I can do that?
I think same force will be there.
Same force can be transferred?
Yes,
No, that's not correct. Okay. So that is an, please listen, yaar. If you are attending something, you are jumping to torsions and just answer this, no? Okay. So, guys, please concentrate. Okay. You might be thinking that, okay, this may be very easy. I don't know what I'm speaking, but if you listen, then you'll be able to understand. Okay. So let us see, we are transferring this force from this face to the center line. Okay. Now, almost most of you have given that extra moment. Okay. Now, for how that moment will be coming? For that, we need to know the distance. Okay. This distance, which is there from center line to the nozzle face. Okay. Now, let us say that distance is X. Okay. And that value of this load is FL. Now you give me the value of the moment. Okay. Now you can write either plus or minus with sign I need. So whether finally that F will be increasing or decreasing when I'm shifting, that is very much important. So Jagdish is saying minus. Uday is also saying minus. Minus FL into X. Absolutely right. See, finally, what we have to do, we have to balance, right? So when the moment is here, it is creating a moment at this location, at about this nozzle in this direction, in counterclockwise, anti-clockwise. Okay. Now, if I'm shifting that load to here, whether that moment is there now. Now that moment is gone. Right? If I've just shifted that force to here, that moment is not there about this point, okay, which was earlier there. So the moment value will be positive or negative again. Now, see, moment is gone now, but I need to balance it, right? I need to have it. I cannot ignore that because it was there. Okay, so this moment will be added in moment, and that moment will be what? That is ML, the longitudinal, the moment along the longitudinal direction. So all the moments, there won't be any change. All the moments you can transfer from this point to this point. Okay, but now what will change? That ML will change because of this. There will be some addition or subtraction because of this shifting. Now you tell me whether there will be addition or subtraction in ML. I don't know whether you guys are getting it. So they're saying subtract. ML value will decrease or it will increase. There will be no moment. Okay. So I think there is problem in explaining. Let me just try again. Okay. So this is a force. Okay. This is FL. Okay. Forget about all other forces. There are no other force or moment present. Okay. Only one load, which is FL. Okay. But I don't want to apply FL like this. I want to mention the same load at this junction. So can I directly say that FL load is acting at the center with no other effect? Whether I can say that FL I'll just shift without any other effect? Abhishek is saying yes. What about others? See, FL I'm shifting from here to here and saying that that's all, my forces are balanced. Yeah, this force create moment in the vessel. This will be effect on FL. Effect on FL means what? That is what I'm asking. What effect? Sanjay Sharma is saying counterclockwise moment at the junction. Okay. So there will be some additional moments. Do you agree with that? See, it's okay. I'll just try to explain again. Okay. Okay, let us again consider this at this point. Now we are talking about a point which is here at the junction. Okay. This is the point which we are concerned about. Okay, the red dot. About this point, what is the effect of this FL? What this point will see? This point will see a load which is FL and also a moment, right? Because of this load, there will be moment, right? Which will be FL into X. If we are taking counterwise as positive, counterclockwise, then it will be a positive moment which is created by this FL, right? Now, I want to shift this FL at this point and having the same effect. I don't want to exactly overall change anything, just want to consider this load or transfer this load to this, which creates same effect. Okay, so what I'll do, I'll shift this with the same value FL and also add one FLX moment. Here it was only FL load. There was no moment at this point, but at this point, this was the moment created by this. There was no additional moment, but this moment was created by this force at this junction. Now, if I just shift it here, then this moment is gone. No, there is no moment created by this FL about this point. So this is gone. But if this is gone, then this shifting will not be having the same effect. Okay, I want to have same effect. I cannot no, this moment which was earlier there, it has to be there now also. Then my shifting can be said that it is equally, or same effect has been created. I cannot change. I cannot change the forces. If I'm shifting, I'll have to compensate for that. Okay, so there will be a moment created like FLX value that will be added in this direction. Okay, which you can mention like this. So in longitudinal direction, there will be a moment coming. Now, if the earlier moment, if it is in the same direction, which is longitudinal moment ML, then it will be added. If it is in opposite, then it will be subtracted. But this force, like, this two scenario are same. I'll just can mention that. So this is one scenario, and this is the second scenario. Okay, so both are equal. Here only moment is the only force is there in the second, force and moment. Okay, is it clear, guys? This both, like the scenario in the first case, I can mention in the second way. It's a different way of giving the same load. Okay, we are not changing anything. We are just giving it in a different manner. Yes. Okay, so it is, it should, if we are changing it, it should have a same effect. Okay, that is what is the intention. So at this point we are considering, then at this point it should have a same effect. Okay, great. So now so for all the loads you have to do the same activity, so that you can find exactly, convert that phase load to the load at junction. Okay, and perform the WRC calculation. Okay, so that will be solving your first part. Analyzing, you will do the WRC calculation now, and then your first part is taken care, the WRC of the junction. Okay, this part is taken care. Now, the second thing is about the flange. Okay, why we need derating? What is getting affected of this flange because of the load? Okay, what is changing for this flange because of this load. Okay. So now again, consider all the 6 forces, okay, which is here. This is also very interesting. Weld, definitely there will be additional forces on the weld. So weld is more stronger than the nozzle neck. So basically you have to check the nozzle neck, which will do. That will be the third part. Okay. Right now we are talking about the effect on the flange. Okay. Just concentrate. We are talking about on the flange, what will be the effect of these 6 loads? So Abhishek is saying pressure retaining capacity will reduce because we have selected a flange based on rating, and which is taken by pressure and temperature. Okay, these are standard flange. Only pressure and temperature is considered, and based on that, these are created. Okay, they are standard items. It has been never considered that there will be some extra load coming on that. Okay. Now in our case, there is extra loading coming. So can I say that still it can be, it will be able to take the same load, same pressure and temperature, or so? No, right, Akash? So definitely we don't know how much strength has reduced, but definitely we feel that, okay, now because apart from pressure and temperature, there are other loads which are present. Okay. So because of that other load, pressure taking capability of this flange may have reduced. Can I conclude that? Can I, everybody is getting that? Can I say like that? No, there will be some, problem with, or the reduction is the capability of this flange. Okay, we can conclude that. Now, let us see which force exactly is bothering you. Not all the forces will create problem for flange. Now let us talk about that. Radial force P, whether it will have any impact on the pressure taking capability. Just imagine this another flange which is trying to see, this load is created by what? There is another flange, okay, and there is gasket present in between these 2 flanges. Okay, there is a gasket also. So what is basically happening? This load okay. Yeah. So this is the gasket. Now, radial load P. Do you think anything happening with it? See, finally, we are worried about the leakage. Right? This purpose of this flange joint is to perform and contain that pressure. Not only retain its shape, but the main purpose is to avoid leakage. Okay. So whether this pressure, which is the radial load, which is coming in this direction, do you think it is creating or damaging that capability anyway? Do you just feel that, I don't know, don't want that value, but do you feel that because of this radial load, okay, there can be problem with the flange taking capability? See, much or less will depend upon once we do the calculation. First, whether it will have or not, that is the question. Much or less can be told only when we calculate. Akash is saying yes, Anand, Pankaj and Uday is saying no. Okay. Let us take one more load. Maybe that will give you some idea. The torsion load. Okay. Or let us say this, even this load, FL. This load will have any effect on this flange? FL. Okay. Lots of different answers. Yes, no, yes, no. Come on, still not everybody is responding. We have 19 people, 18 now. So what do you think? Yes or no? Okay, lots of yes, few no. Okay. See, this load, which is, exerting a force in this direction, okay, that is parallel to the actual ceiling load. Okay, so it does not have any impact on the ceiling. This load, if you see FL, radial load P, that is exactly, see, this direction may be even opposite. See, if the earlier direction was not bothering you, now this may have some botheration, that it is trying to make them separate. Okay, so directly impacting your leakage. So it is having a direct impact. While FL, it is in perpendicular direction. Okay, so basically that bolt will experience some additional load. Okay, other than that, your flange will not have affected by that. Okay, so what is impacting is P. Okay, FL and the circumferential direction load FC will not have any effect, and that will not participate in the reduction of this. Abhishek saying bolt will transfer to the flange also. Yeah, but see, that is very insignificant because the direction is parallel to the leakage surface. Okay, so it will transfer to the flange will transfer to the neck. That will do the separate calculation, for the it is trying to basically bend this, okay, that nozzle neck, which will do one calculation. But for leakage, it is not, creating much trouble. Okay, much, or we should say actually no trouble, because we are not doing any calculation. So that itself indicates that it will not create any problem. Now, if we talk about moments also same thing happens. ML will have any impact. ML, when I say, it will have the same direction which we have indicated here. This is ML. Okay, so moment in the longitudinal direction. Whether it will have any impact? So they're saying yes. What about others? Yes. Okay, it is finally trying to bend. Again, it is trying to separate. One place it will provide compression. Other side, it will try to elongate. So it is having direct impact on the leakage. MC, which will be, you can consider this from the top, and there is a moment created. For that direction also, it will be looking like same, right? So are you guys getting it, or I need to create that? Tell me. For MC, are you able to visualize? There will be, this vessel can be seen like this. There will be nozzle like this. Okay. And then there is moment acting like this. Okay. So if I rotate, it may be, okay. And I think Z, I need to rotate. Come on, guys, tell me if I'm able to get, otherwise I'll have to create this the way I, yeah. So this is the circumferential moment. Again, in this view, it is looking exactly same as ML in the other view. So there is a flange like this. There is a flange of the pipe. It will be like this. So finally, it will try to compress one side and elongate one side. So again, it will have the same effect what this ML is having. Okay. Now, if we talk about torsion, MT, which is just trying to twist that flange, it is twisting this flange, MT. I hope you remember the direction. There is flange, okay, and trying to twist. Okay. That will have any impact. Again, it is going in the parallel direction. So it will not have any impact. So if you see the formula, you will be able to relate what I'm saying. Okay. See, this is the derating calculation. Now, if you see here, okay, ME is the external moment. Now you'll see only one external moment is given. What about what we figure out that MC will have effect and ML will have effect. So both should have been there. Why only ME is there? So ME is the resultant of MC and ML. Okay, that is the resultant external moment. FE is the tensile axial force, which we call as P, radial load. Okay. And no other force or moments are taking like FL or FC or MT. These three are not present. Okay. So basically that is the conclusion, that they don't have impact. Okay, great. So now we know that there will be again coming back to the start. So we were talking about derating, right? So we understood that why we need to derate, because there are external load which are trying to reduce the capability. So we need to take care of that. Okay, so that is the reason we perform derating. Now, whether derating has to be by UG 44B. See, now derating will be required. Okay, how you have done that is secondary part. Whether once you submit the report, once it goes to AI, and let us say you have not performed derating, he will look for the derating, right? He will ask the same question, because of this load, there is going to be problem in the flange. How you are taking care of it? Okay, so you will have to say that I need to derate. I need to consider that there will be some effect. Okay, so now you can either use 44B, because if you read 44B, it starts with external load may be evaluated, okay, by using that following formula. And this is only for weld neck, only for W and RF. Remember that. You cannot use this principle for any slip-on or any other type flange, only for weld neck. So weld neck flange may be derated by using this methodology. You can use that, maybe is as good as it is available as a method to us. So if I used, my rating was increasing, I was not able to qualify, let us say, with 150 rating. So I need to increase to 300 rating. Okay, but I don't want to do that. Then what I can do? What is the other method? Yeah, long weld neck is weld neck. Lagamanna. It's long weld neck or normal weld neck. It is applicable for weld neck. To reduce pipe load, we cannot do that. We cannot reduce pipe load. Okay, so if I don't want to increase the rating, then what is the other method? What can be the other methods? You tell me, where the flange is calculated. Sumit is saying qualify through FEA. What about others? analysis. So Lagman is also saying FEA. MAWP to design pressure. How that will help, Manoj? The MAWP design pressure will help only you in hydro testing. Okay. So there is a flange design available in mandatory appendix 2 also. Guys, in mandatory appendix 2, we can design the flange. So what I'll do before going to FEA, you see, increasing thickness may not be required. See, now we are using a different methodology. All these are standard flange. They are not based on any calculation. Okay. So what I'll do that I'll take the same dimension. I'm not, see, non-standard does not mean that I have to change the dimension. I'll just, for designing, I'll consider it as a non-standard and use mandatory appendix 2, where I can take care of this external load also. I can apply the external loads for evaluating the front. Right? Or wrong? Can I do that? Sumit, Uday. Guys, to check we can do. No, we are not talking, we are talking about the submission of that report. So what we are deciding here, that instead of derating using 44B, I'll consider it as non-standard flange. By non-standard, I don't mean that you have to change that flange. Flange dimensions still will remain same. I'll just use those dimensions to run that calculation in appendix 2 method. Okay, where I can apply even the external loads. Right? So we will be able to justify that this external load I have considered in my design. That is the reason why I'm going in appendix 2. Okay, because there are methods of applying that external load. So now if I use that, then AI will not be able to ask the question that, how you have taken care. If it is asking how you have taken care, you can justify that this is how I have taken care. Okay. So you don't need to go to FEA. Okay. Now, if I want to go to FEA, okay, let us say now this is the scenario. Even by using mandatory appendix 2, what was happening that I had to change, either increase the thickness or change some dimension. So if I have to do that, that means that flange will actually become a non-standard, which you have to start from making it as forging and then machining and making it. So that is increasing my process. So I thought, let us go with FEA. Can I do that? Can I use FEA in place of mandatory appendix 2 when section 8 division 1 is applied? If no, then why? Why I cannot use, or if yes, and how you are using it? Like, somewhere it, you remember U2G, right? Let us go to U2G, because once I have to use FEA, I need to go through that route, right? So the question is, if we go to FEA, then we cannot qualify for USTAB. No, I'm not saying that, Sumit. I'm saying how you will go for FEA. Okay, to again simplify that, let us make it very simple. There is a shell, okay, a cylindrical shell. I had some plate already, and by using that plate, I wanted to make that cylinder. Okay, once I did section 8 division 1 calculation by using UG27, my shell was not getting qualified. So what I did, I went for FEA. I did FEA, now it is getting qualified. Can I do that? Okay, forget about the first question. Now focus on what I've just asked. I hope you understood that. There is a shell with particular thickness. I want to maintain that thickness. Okay. But when I used UG27 formula, my thickness was not getting qualified. So I went to FEA. It is getting qualified. Can I do that? Uday is saying no. What about others? Come on, guys, respond. I think all of you should respond. Should be able to respond. Can I use FEA? Abhishek is saying yes. Manoj is saying no. Sumit, no. Uddhav, no. Udayji, no. If no, then why? Why we cannot use? Why we cannot use FEA in that case? I'm talking about the shell case. Why we cannot use? If there is no methodology for design, then use FEA. Absolutely right, Akash. Absolutely right. Okay. See, we can use FEA if you again now you refer U2G. See, U2G is bridge between using, section 8 is having two different division. Okay, if your design code is division 1, don't jump to division 2 directly. You cannot use anything, right? Division 2 is a separate code. Remember that. So I cannot make a mix up of all these codes. Okay. If I'm going to a different code, there has to be proper bridge. I need to cite the clause which is allowing me to go there. So this is the clause which allows you to use division 2, but there are lots of if and buts. So let us try to understand. This division of section 8 does not contain rule to cover. So division 1 agrees that, see, there are very less rule available, or it does not have rule for all the kind of design. So where complete detail of constructions are not given, you can use the appropriate method, which is given in 1, 2, 3. So what is the first? Where design rule do not exist in this division. This statement is very much important. When design rule do not exist. So if the design rule exists, can I go further? No. If the design rule exists, we cannot even go to the next statement. This statement or this clause is applicable only when design rule do not exist in division 1.
नहीं मैं छेड़ूंगा तो आज सुबह लिखेंगे तेरे.
Okay, so design rule, if do not exist, then I can go to mandatory appendix 46, which exactly tells us that we can go to division 2. There are lots of rules to that. What is the major rule, or what is the rule which is very, very important? That is allowable stress. What allowable stress I'll have to use when I'm jumping to division 2 from division 1 for the part where I don't have design rule? What should be by allowable? That should be not division 2, division 1 stresses, because the code is division 1. Okay. So if you refer mandatory appendix 4, you will see lots of rules that how you can use. Okay. Now, in this case, now coming back to the flange. Okay. For the flange also, your AI can take that stand, but you already have mandatory appendix 2, where there is method to check this case for the nozzle overload. How you can jump to division 2? By passing that rule. Okay. See, because code does not talk about derating as a word. If you see even 44B, there is no derating word. Okay. So basically, we are trying to check that flange for external load, which is available by using mandatory appendix 2. If you're not able to do with 44B, use mandatory appendix 2, make it as a non-standard flange, apply those loads and check. Getting it? So can I use FEA for derating again? No, we cannot use FEA for derating. Okay, because there is no jumping. If the rules are available, you can. If by appendix 2, if we could not, failing does not mean that you can jump. Okay. See, the first clause is not saying that when by using this rules, if the component is failing, then then you have to go and use division 2. It's not like that. Failing or passing, if the rules are there in division 1, you have to follow that. Okay, if rules are there in division 1, you have to follow. Okay, clear? So you cannot avoid that and jump to division 2. Why? For WRC, for radials and all, we can go because there is no rule. We cannot apply WRC. If WRC we cannot apply, then we go to FEA by using this route because there is no rule available. Okay. Getting it? So hope now it's clear. Still we have covered only partial of what. Okay, so we started with derating compulsory for nozzle. So now, yes, derating is compulsory. Now the method of doing can be either 44B or mandatory appendix 2, but you have to perform. Okay, the second part, FEA, is also we have clarified that FEA you cannot do. Okay. If appendix 2 fails, then redesign. No, you can always increase the thickness and change that flange, Abhishek. Okay. Akash, you can type the question. Yes, so now still we have covered only the second part. First, we saw the WRC calculation where we analyzed the junction. Second, about the derating of this flange. Third, will be even the neck, nozzle neck also need to be qualified, right? This also you can do, Uday. You can reduce the pipe load by providing, you can suggest piping that use their bellows they can use, they can provide support to that pipe, which will reduce the external load. So that also is possible, okay, to reduce the pipe load. Okay. In that case, what we will do, we'll provide the maximum load which my nozzle can take. And then piping will ensure that your loads are not exceeded. Okay. That is also one option. Okay. Great. So the third will be to checking the nozzle neck. Now, how we will check the nozzle neck? We just create the moments which is caused by the maximum load. And then once I have the moment, I'll use sigma B M by Z. Bending moment is M by Z. And using that bending moment, I can, it will create two different values, compressive and tensile. So check both. So basically for nozzle, you have the tensile load existed because of pressure. So that the tensile load you add with that and check with allowable. The radial load P will create a compressive stress. So that also you need to calculate, add that with the compressive stress because of moments. Okay, and with no pressure case, you can check. Okay, what is maximum it is going. So that is how the nozzle necks are qualified. For the support, you can balance the forces and find out what is the additional moment coming at the support location. And no, PV light does not take care of the nozzle neck. We have to perform additional calculation with that. So we need to add that calculation. PV light does not perform the nozzle neck check for the external load. So remember that. Okay, so always you have to add this. See, many times we forget. Okay, Mini AI also may not be questioning that because they don't see that regularly. But I have seen reports. If you see the report of good companies, you will have this nozzle neck also checked. Now let us say you are AI. So definitely there is a load coming on the nozzle neck. That has to be checked, right? Yeah, AI may ask this. So that time you may have to add, or if you add it beforehand, then he'll be very happy. Okay, for supports, again, same moments will be there. So that additional moment you have to consider. Okay. Yeah. Yeah, so you have seen that. I have seen in many projects where that nozzle neck, also that separate calculation has to be done. Yeah, I'll unmute you there. Yeah, go ahead.
So actually, the software is not getting these stresses, giving these stresses and comparing stresses, qualifying for these stresses. So if it is not the STEM job, it is
Mhm.
so client can ask for this.
Yes.
Client can ask if it is not specified in the
Yeah,
specification.
correct. See, still client. So now it's very simple. Okay. See, STEM job does not mean that any requirement has changed. Requirements are same, but they try to follow each and everything. They don't ignore. Okay. So with normal jobs, we try to ignore. Okay. So some external loads is coming on flange. So it's a standard flange, just leave it. Okay. Nozzle neck, we don't bother. But if you are actually doing the design, and you understand this principle, does not matter whether it is stamp or not. No. Let us, I
Actually,
am the
sir,
client. Okay. And you have submitted the report. We are checking it. I have given the comment like, for this load, there will be additional stresses coming on the nozzle neck. Show me that calculation. What will be your reply? Can you say that no, code does not ask for that?
no, sir.
Right. So that there you will face problem, right? Like if I'm asking that what nozzle neck, why that flange rating has not been done? Because there are external loads. And as a good engineer, I can say that there may be a reduction of pressure taking capability of that flange. So how you are, I'll just ask question. You have to answer because you have done the design. Okay. And if that answer satisfies me, it's okay. So that is what AI also does.
Okay, sir. But sir, the problem is that I've
Mhm.
seen that for the stresses in the nozzle neck, same thing about the nozzle loads consideration, the support design and foundation loads.
Mhm.
So the like in my one job, there is a and there is a EPC and then is a PMC.
Mhm.
So EP is saying that don't consider nozzle load because it is enhancing the foundation loads, and our foundation is becoming bulgy, and we have to bear that cost
Yeah,
for the
so see
foundation.
that is case to case basis.
And
So as a designer, you have to take that in writing. See, let us now assume that some problem happened after 5-6 years.
okay.
Who will be asked question? Who has signed that design report?
So actually, I was discussing this point. So they said the EPC people said that the consultant has not specified that to use this loads in the foundation. So why are you considering?
No, still, as a designer, you cannot, uh, uh, you know, uh, this is your responsibility to design that. Uh, See, definitely he will be also asked the same question. Let us see if there is some penalty given for that failure which happened, then both of you will be responsible. But you also cannot say that because they have not given. See, you as a designer are responsible to design it, that vessel, in complete manner, right? He can always assign or give requirement which is additional from code. That is well and good. But the question will be simple. No, like you are sitting, something happened and people are asking question. What they will ask, Uday, do you see because of this load any effect coming on the skirt or the foundation? What will be your response?
So the point is valid, but sir, if it fails in the normal methods, when can you go to FEA for the support designs?
Fails in the normal method means?
Like the methods given in the books
See,
that we are using.
okay, see for skirt is a non-pressure part.
Yes, sir.
Okay, so you can do whatever you want to satisfy that. See, even
Okay.
now you don't use code, we use methods in Bednar, okay,
Yes, sir. Yes, sir.
to qualify that. But so that is anyway in you can do FEA for that.
Okay.
Okay, that is possible because it's non-pressure part, so you are free to apply whatever method you want.
Okay.
Getting it?
But
So
no, for not for nozzle necks.
nose for nozzle neck is a pressure part, so you have to use the methods which is
Okay. So we
there
should
in the
check.
code. Yeah.
Even client is specified, and there is. We should check at our end for the necks as well.
Yes, yes. See,
Okay.
whatever effect we see as an engineer, the question is very simple like that. Do you see the difference? Do you see that load will have any stress? So you have to say yes. Then they will ask why you have not done that. Getting it? So it's pretty simple. They will just ask that, do you feel that there will be any additional stresses coming because of that load? You'll have to say as a good engineer, yes, there will be definitely some effect. You can say there will be very minor measure, but then again, the question will be, how do you see without calculating, how you can say it will be minor?
Okay, sir.
Okay, that is how it comes, when you set an approval for your report. Those are the question AI. So AI is just a representation of a person who is checking your thing. He can be anybody. It may be use stamp, non-use stamp, does not matter. Okay, great. So I think now we have spent a lot of time on that question, but this was, I think, pretty important and lots of time people have this query. So I spent a little extra time, but don't worry. Akash is saying I have posted question. Yes, we'll take care of that, Akash. Don't worry. So next question is by Abhishek. Can we use carbon steel material for liquid CO2 storage at temperature minus 78 degrees Celsius? Guys, tell me what should be the answer. Can I use carbon steel at minus 78? I'm asking to you guys. Uday is saying no. Manoj is saying no. What about others? Don't know. Akash is saying no. Lagamanna, no. Okay, if no, then why? Why we cannot use carbon steel at minus 78? Only till minus 29, Akash? We cannot go below minus 29? Uday is saying I've seen till minus 46. Yeah. See, the reason for not using at low temperature is the problem of brittleness. The material becomes brittle, and we don't want to use a brittle material because that failure will be catastrophic. Okay, that is the simple reason. Now, at what temperature I can use, that will depend upon the whether that material is brittle or it's still ductile. Okay, so below minus 46 or minus 48, okay, up to minus 45, 46, we can use the MDMT exemptions, do the calculation, can satisfy even without doing impact testing. Okay, but if any doubt is there, we can always do the impact testing and make sure whether it is ductile or brittle. Okay, so below minus 48, definitely you have to do impact testing. And see, it will be very rare that at minus 78 that steel remains, the thickness is considerably good enough. it's very rare that it will pass the impact testing. Okay. So I have also not seen any carbon steel material getting used at -78. So very, very rarely that it will pass that impact testing. But in case you have produced a material which is able to pass the impact testing, you can use that. That it will be very, very rare. Definitely that depends upon the thickness also, but it will be rare to. So Abhishek is saying, okay, I'll just try to unmute you. Yeah, Abhishek, go ahead. You can unmute yourself now.
Hi, sir.
Yeah, hi.
I'm audible?
Yes, please go ahead.
Actually, in my company, we are using carbon steel material for
The
storage
voice
of
is very, very low, not audible.
now.
Repeat again.
So actually, I'm not audible.
Still, it's pretty low. Speak again. Hello.
Sorry. Now I'm audible.
You can speak. Still, it's
Okay.
low, but we can at least.
So I was saying, like in my company, we are using carbon steel material for storage of liquid carbon dioxide.
Mm-hmm.
So I was worried, like in course I was read like last time also we have discussed regarding impact testing and of
Because
course,
you guys are already using it. What is the thickness, Abhi?
so thickness is also around near about 1 inches.
25 mm. Not very high, but it's really not a good practice to use that. I hope you guys are doing impact. See, even code does not matter to that. Okay, this is the matter of safety. So even code will not say anything about that. You have to do impact testing for the material to remain. No. So even though you are not following code, so whether you are following section 8 division 1, Abhi, what is the code, design code? So Abhi saying yes. So section 8 division 1 you are following and using. So have you done impact testing? Are the materials impact tested? Yeah, you can unmute.
No, sir, they are not also doing the impact testing. Like I have raised the query regarding this, like methodology, how we are
Impact testing
following.
is not done, you're saying?
Not done.
Or yeah, it's
That's my concern also, like how they have clarified and they are doing since last 30,
try
40
to check,
years.
no? Try to find out. I will be also interested to hear, what is happening, why. So
Correct.
they might have a very valid thing. They might have done very long back some impact testing that was qualified and the same source they are using, but still, even you have one time for one batch you have done impact testing and it is passing. Still, for the next batch, you have to do impact testing and qualify because materials are different. Even the same supplier is there. And what is the grade?
Grade 70 only.
Grade 70.
Yeah.
Very rare. I have not seen carbon steel getting used at -70.
And also like for SS material for storage of liquid hydrogen and liquid helium also, they are using SS 304, 243 L
Hmm.
material for like -268, -253 liquid hydrogen is there. But
Hmm.
still they are able to qualify -196 degrees centigrade MDMT. I don't know
Hmm.
how.
-250.
-253 is the boiling point of hydrogen. So they are using the same material. Like on Friday also, I did the same calculation because they have predefined templates for that.
See, when SS, you cannot go up to -253. So there is a limit for that also. If I remember correctly, it's roughly
Yes,
around -196.
-196 is the
Ah,
limit as per UHA.
so you cannot go. I don't know why, how they are doing it.
They
Try
are
to
doing
find out,
exactly.
what is happening. Okay. Because see, unless the failure happens, everything is good. Okay. nobody cares anything. Once the something happens, then it will be investigated that how that happened. Okay, so that time everybody will be in suit. So better, just for information also, you can try to find out what is happening. 80, 90 years, so that might be their confidence. But try to find out. Definitely you'll get some idea, how they're able to do it. Must be some valid reason for them to doing it. Something, some backup. Still, it's difficult to see what it will be, but really surprised. Okay, great. So now let us move to the next. Try to find out. We'll love to hear, if you're able to find something. Okay. Next thing, Abhishek has asked, in first para of UCS 23, what is the actually increase regarding allowable stress for service temperature? Let us go to UCS 23. Okay, so you're talking about this one. In UCS 23, increase. Okay. So section 2, bolting and table 1A for other materials, give the maximum allowable stress. Okay, we know that. Values may be interpolated. Okay. For vessels designed to operate at temperature below -29, the allowable stress value to be used shall not exceed the value given for 40 degrees. That is okay, right? You're getting it? So like, if you see that section 2D, subpart 1 tables, you'll see the allowable stress given only up to 40 degrees Celsius. Okay. 40 your room temperature, 25 degrees Celsius. If you go below that, the question will be whether what allowable I'll use. So even if you are below -29, still you have to use the same allowable. That is what it is clarifying. You cannot exceed. No, definitely that is the maximum value which is given at the room temperature. You cannot exceed. No, you like for high temperature, the strength reduces. Does not mean for low temperature, strength increases. It remains constant. Making sense now, Abhi? And to all of you, any doubt in this? My design temperature at -20. Yeah, -20, -40. Allowable stress will remain same what is given at 40 degrees Celsius. Yeah, same allowable you'll have to take. Okay, great. Now the next question again by Abhi, 68C. Let us try to go there. Yeah, so is asking, please explain for PWST exemption and what is saying regarding -40. Okay. So this clause is pretty clear that if post-well heat treatment, okay, it is performed when it was not required by this division. That means what? The thickness might be in less than 38. If we're talking about P number 1 material, because this clause is applicable for P number 1. So for P number 1, if my thickness is less than 38, then I can avoid PWST, right? Yes, no? Guys, if to all of you, if my thickness is less than 38, I can avoid, right? But still I'm doing. It may be because of, yeah, preheat, between 32 to 38, I can use preheat and avoid. So code is saying, but still you performed post-well retreatment when it could have been avoided. Okay, that may be the Abhishek like lethal services or source services. So it's because of process requirement or any other requirement you are doing PWST. Okay, in that case, the 17 degrees Celsius reduction in impact testing exemption temperature is applicable. That UCS 66 which we used, we got the exemption at certain temperature. You can reduce minus 17 degrees Celsius. Let us say we got 0 degrees Celsius as per UCS 66. We can go up to minus 17 and will be exempted. Is it clear? Okay, I'll unmute. Yeah, Abhi.
So the question is this clause only applicable for lethal and source service?
No, it is not saying like that. See, maybe you may have a different reason for doing post-weld treatment. It's not lethal, it's not source, still you are doing. Maybe for reducing the hardness of the weld. Maybe that fiber elongation was more. Getting it? Stress living. So we are not performing because it was required as per PWST clause, but you are still performing it. Okay. So the main reason will be the process requirement, like it's lethal or sore. No, that is the 90% cases which you will be using. Other than that, maybe the client requirement or no. So if you are using that, then yeah, see whatever like caustic service, and it is a mandatory based on that code, and you are doing it. So that is kind of process requirement. So if you are doing because of that, you can reduce that impact testing exemption by 17 degrees Celsius. Is it clear? Okay, and the second part of, if that is clear, then I'll go to the second part of the question. Yes, no? Okay. Now the second part is saying the resulting exemption temperature may be colder than minus 48 when the PWG exemption. So you can go even if, let us say you subtracted, your temperature was in UCS 66, you got, let us say, minus 35. Okay. And you, because of this clause, you are getting minus 17. So minus 35 minus 17, you will be getting minus 52. So you can go up to that. Okay. Getting it? So how much deeper you can go, that is not, you cannot go up to minus 104, Akash. Okay. It is just saying that you can go, but then there is no exemption as per B, if applicable, then you'll have to read B for which cases that exemption is applicable. Okay. Yeah, so B exemption means this clause, UCS 68B. It is referring to this clause. Okay. So if it is exempted based on this clause, then you can go up to minus, even lower than minus 48. Okay. Oh. See, you are getting confused because you are referring this also. Now, if you read this, then it may make some sense. Let us read this. So welded joint shall be post-welded treatment accordance with UW40 procedure. So here it is talking about only the procedure. When the minimum design metal temperature is colder than minus 48 and the coincident ratio is 0.35 or greater, PWST is required. Okay, so now in this case, you won't be able to get that or lower than minus 48. Except now here your exemption is coming. Except that this requirement does not apply to the fabricated part from P number 1. Okay. So if my material is P number 1, I can go up to even lesser than minus 48. That is the basically this clause. For P number 1, if you are doing PWST, when it is not required, then minus 17 degrees Celsius you can do. And that resulting, if it is coming even less than minus 48, then also it is valid. You can go up to even minus 52, minus 55. Okay. Getting it? Now it's clear, Abhi? Yes, MDMT will be what after minus 17 degrees Celsius, what is getting, that is will be your MDMT. Yeah, like minus 55 will be your MDMT. Okay. Yeah, so if that is clear, we'll move to the next question. Abhi? Yeah, it can be a case where we can go below minus 48. That's what we are saying. Okay. Great. So Jagdish is asking next question. It is about UW12. Okay. Is asking one seamless pipe welded with two seamless Tory spherical heads, both end. Okay. And circumferential joint backing ring remaining in place. Okay. So that means it's type 2 joint. RT2 for one case and 11 and B, 11A5B for second case. What is first case and second case? Jagdish is there? Yeah, Jagdish is there. Jagdish, I'll unmute you. Can you just ask the question?
Yes, sir. Good morning, sir.
Yeah, good morning.
This first is if the complete vessel is applicable for RT2, and second case when it is completely applicable for UW11A5B.
Mhm.
Two different cases.
Okay, so let us talk about the first case. Okay. So in that case, you are saying that complete vessel, and that vessel is what? It's a seamless pipe. Okay. And seamless dish ends. Okay. Only the two surseams are there.
Yes.
Right. So if RT1, so you're saying if RT1 is applicable, then what will be the joint efficiency? Like this.
RT2.
So if RT2 is applicable, then what will be the
Joint efficiency.
Okay. So basically in RT2, what we do? What is the definition of RT2?
RT. This all long seam A and D joints, like full radiography, and surseam spot radiography.
Correct.
Except that nozzle and chamber connections.
So nozzle chambers and the connecting chamber, that the different requirement. There are some exemptions available, but other than that, RT1 is very simple. All full radiography. Okay. For RT1, except that chambers and all. Spot radio for RT2, all the long seams again full radiography. For some surseams, we have spot radiography allowed. And because of that, what happens? Do we have any change in design if we follow RT1 or RT2? The thickness, if we talk about?
Yes, joint efficiency will vary. So according to thickness will vary.
Thickness may vary when your longitudinal forces are governing. Otherwise, it will not. Okay. What I'm saying. Just make a simple vessel. Okay, let us take one more. Okay. Now, just give some. I hope you can see the screen. Yes.
Yes.
Yeah. So let us first make this external pressure go away. That will make our life easier. Okay. Now let us increase the thickness, make it 10. Okay. For the second one and also the first one. Okay. So we have all the two elements with same data. Okay. Now, my longitudinal, this is my joint efficiency. Okay. If I just click on this, you can have a different requirement shed, based on this data. You can have a different requirement for different type of radiography. You can mention for long sim and SIMs. Okay. So RT2 means what? If I have a type 1 joint, okay, in your case, you have mentioned with backing ring, then that means what will be my joint efficiency?
Type 2.
Type 2. For that, for long sims, what will be my efficiency if I'm doing 100% radiography?
1. Joint efficiency 1.
Then it will be 1.
Yes. But in our case, there is no long sim. Seamless. But
It's seamless, but let us see if it
yeah,
seam is there, then what?
then it's 1. Joint efficiency 1.
Guys,
Full radiography.
for full radiography for type 2 joint. Just
Then
see here.
0.9. But still, for this SIM, it is backing ring remaining in place.
Correct.
For
So
long
I
sim, it is
got
not.
it. I got for this, the case which you have indicated, that is not valid, but just for knowledge, we are sharing. So type 2 joint, it will be 0.9. No? So in our case, we don't have the long sims itself. So it's a seamless pipe. So definitely that will be 1, as good as doing full radiography. For circumferential sims, I'm doing spot radiography. Okay. And the type is type 2. Now you tell me what will be the joint efficiency for this case.
Is 0.8.
0.8. So we'll just write here 0.8. Okay. Now anything is changing in the.
But is it correct, sir? This 0.8, because somewhere I got it 0.65. So that's why I confused. That's why I
No.
put this question.
Somewhere means where? There is only one code, right?
Yes, sir. Somewhere in this is the question I just got in the
No, see, you should be
during
very
preparation.
careful while referring. So code is only one. So if type 2 means if backing strip remains in place, then it is type 2. And if you're doing spot radiography, then joint efficiency will be 0.8, which is as per code. So that is what will be valid. But now if you see here, if I take 0.8, then also there is no change in the thickness required. Is it? If you can notice that 9.31 is required. If I change to 1, still 9.31. Why this is so? Why it's not changing? Even if you go to 0.65, that does not mean that you have to mention 0.65, but I'm just indicating 9 not changing. Now let us make it 0.5. Still not. Now let us reduce it 0.45. Why it is so? Guys, not governing. Okay. Because circumferential stress is governing, which is, which acts on the long seams. Okay. So that is the reason we have, even if you have RT2, and RT2 only if changes that SIRSIM's efficiency, it will not have. So now if you are if you're having other loading also, let us say wind or seismic is there, in that case, once you apply that load, then there will be having additional stresses in longitudinal direction. So that may add to the longitudinal stresses, and then your longitudinal stress may become governing. In that case, it is very, very important to put the right value. So see, because we have not modeled it completely, we have not modeled wind or seismic. So once that is there, then it will have more meaning. But typically, if you see RT1 and RT2, you will get same thicknesses. You will not have much difference, and that is the reason RT2 becomes favorable to fabricators. Getting it now, Jagdish? Is it making sense?
Yes, sir.
Okay, thank you.
So if in another case,
Yeah.
if there is a long seam in that cell, if there is a long seam
Okay.
and this RT2 is applicable
Mm-hmm.
and descent is seamless. So that case, what will be the joint efficiency of the surseam?
Surseam between descent to
Cell
shell.
and cell, yes. Descent to
Same
cell.
like.
And is it torus spherical descent?
Yeah, so torus spherical descent, it will have a straight face, right? And you are welding finally a shell to shell only.
Yes.
So it is as good as welding two shells. Okay, and if RT2 is there and you are having backing strip, then 0.8. Okay, if you are not using type 2 joint, you are making a type 1 joint without a backing strip, then you can get 1.
0.85.
0.85 for if RT2 is there. Okay, for surseam, and spot is there then. If you are using full, then 1. Okay.
And for heads, sir, is for seamless head. So what will be the joint efficiency in this case?
If it's seamless, then 1,
UW12D.
no, because there is no weld. So it will be 1.
Yeah. That is as per UW12D.
Yeah.
12D will be applied.
So 12, I don't know what is 12D, but what is 12D?
D is for seamless part of the vessel or descent.
Seamless vessel construction.
meeting-
So it takes, you can take always type number 1. Type number 1 means it is as good as having a best quality of weld, right? Because there is no weld. So seamless means the weld is perfect. That is what, by making type 1, we try to simulate that the weld is as good as base material. If that is as good as, then efficiency will become 1. Okay, so
Sir,
for
can you,
seamless, it's already there.
Yeah, sir, can you elaborate this UW11A5B?
Yeah, we can see that. Okay. See, now UW11 talks about full radiography. So in which cases we need to go for full radiography. So first one is if there is butt welds and it contains a lethal substance, then full radiography becomes applicable. All butt weld joints exceeding 38 mm, then also it becomes magnetic. Like that, there is the 5th clause, all category A and D. Category A is what? Category A
Long
is
seam.
long seams. Category D is what?
This nozzle joints, nozzle to
Nozzle
shell or
to
descent.
shell joint, right? So all category A and D butt welds is talking. So no, D is also butt weld. That means the nozzle will have neck, means lip
Lip joints.
lip joint, and then it will be welded. So category A and D butt welds, where the design of the joint is based on joint efficiency permitted by 12A, UW12A, in which case, now there are 2 different cases. Category A and B welds connecting the shell or heads, okay, by type number 1. So if you have considered it's a type number 1, okay, then and it's butt welded. If you are taking if joint efficiency as 1, then what will be your requirement of radiography? You see, you are taking it otherwise. What we are saying that you are following type number 1 joint. Okay, you are taking this radiography requirement from this A. That is 1. That means what radiography you have to follow?
Full
Full.
radiography.
Yeah, so it's just saying the same thing in a different way. Like if I'm designing by using that, I'm a designer, I have considered the efficiency as 1. That automatically means that I have to do the full radiography because I cannot achieve otherwise. Okay, so for even B and C, butt welds which intersects the category A butt welds. Okay, see, now here you'll have different requirements. So now we are talking about category B and C. B is SERSIM and C is the welds with end, like it's a flange or tube sheet.
Flange connection. Yes.
Yeah. So, but all are butt welds because in joint efficiency, we always consider butt welds. Okay. Other than that, we will not have, the type itself will not have meaning. So category B or C butt welds, which intersects with category A. So category B typically will intersect with A, right? Because long sims will intersect with SERSIM for shell. Welds in the shell or heads of vessel or connect seamless vessel shell or head as a minimum meet the requirement of spot radiography. Okay, so if full radiography is given for a joint, at least your B and C should be done with spot radiography. That is the minimum requirement. You cannot say that I've done full radiography for long sim and for category B and C, SERSIM and the ends which are connecting with shell or nozzle, we are just doing no radiography. You cannot do that. Okay. If you are doing full radiography for long sim, at least spot radiography you'll have to do for the SERSIMs. That is a minimum requirement. Getting it, Jagdish?
Yes, thank you, sir.
Okay. Yeah, so that will become kind of RT2 if we are doing that. Okay, but that is the minimum. Either I'll have to go with full radiography, that will become RT1. If I'm selecting that, okay, for these sims, I can do only spot radiography, then it will fall into RT2 category. But that is the bare minimum. You cannot go and select no radiography for this when your long sims are having full radiography. Okay, that is what it is explaining. Great. Abhishek is asking what, sir, then also it will happen B type 1. I didn't get that. Abhi. See, spot radiography, the type is different, radiography is different. Based on type, you will have the efficiency. Okay. So you can have either type 1 or type 2. There also limitations are given. If you see here, you will get the limitation also. Okay, when I can have, when I cannot have. But if I'm having type 2, then my joint efficiency will change. Does not mean that type 2, I cannot go with full radiography. I can go with that. Okay, great. Thank you. The next question is by Akash. The first question, in heat treatment, when entire vessel undergo heat treatment and when heat treatment performed for welding sims only. Okay, so you're asking when we assign post-weld heat treatment, whether the heat treatment is only for the vessel, means only for the sims, or it is for complete vessel. That is the question, Akash. I'll come back to you, Uday. So, see, the requirement is for only weld joint. It's not for the complete vessel. Okay, Akash. And if you are able to do the PWST only to that all the seams, individually, it is good enough. Like many times we do, see, that is not that easy. It may look easy to you, that radiography, but it's not that easy. Okay. Because there are so many sims, okay, covering all that and doing PWST, it becomes really tricky, maintaining the same data. So what we do, we insert the full job to make it easier for us. Now let us see only one sim, this sim is remaining. Okay. I have to do post-weld retreatment. Then I'll just cover this sim. I'll just cover the sim like this and do the radiography. I don't need to again insert complete vessel because this is my target. There is a PWST zone which has to be maintained, that width has to be maintained. Okay. And if I'm able to do that, I'll do only the radiography of that seam. I'll not insert the full vessel. Is it clear, Akash? Yeah, uniform heat treatment needs to be there. Okay, now you have changed the requirement. What about fiber elongation means? So are you asking what is fiber elongation? In this case, entire. So it cannot happen that your complete fiber elongation, if it has exceeded, then you will do the complete vessel, no? Post-weld treatment is not for fiber elongation. We follow the same cycle, and that is called PFST, post-fabrication heat treatment. That is different. So if your descent, your elongation is increasing, you just take that descent and do the heat treatment. That will be because of fiber elongation. So it has to be entire part. Okay. Now, if you are doing post-weld heat treatment because of welding, then only that sim is to be covered. Okay. So that area of focus is different. In PFST, all the part where that elongation has happened, you need to do the heat treatment. For welds, only that weld part has to be. Now, if you want to take the complete vessel or you want to do only that sim, that is left on you. Okay. Thank you. The second question, how we come to know the number of heating cycles? Okay, very good question. Anybody can tell me how many cycles I need to have based on PWST as per code required? Guys, how many cycles? Cycle means what exactly? Cycle means the holding time, right? Heating and then holding that vessel at that temperature. Okay. If I just draw that, there will be a heating rate. Then there will be holding temperature where you'll hold that. Then you'll cool down. You have to maintain certain heating rate. You have to maintain certain holding time. That depends upon thickness. Heating rate also depends upon thickness, and the cooling rate also depends upon thickness. So this is one cycle. Okay. So now the question is, how many cycles do we have? Should we have? Anybody would like to respond? Manoj is saying 3. Abhishek is saying, I thought it's only once. What is the basic requirement of code? Okay, let us try to understand it with codes perspective first. Okay, let us talk about the first element, which is nothing but P number 1. Okay, so holding temperature is 595, holding time is 1 hour per inch. Okay, so let us see, if I have a vessel of 50 mm, I need 2 hours of holding time, right? If I am able to achieve that in one cycle, I done this PWST, hold it for 2 hours or more than that. Is that good enough? If no, then why? If yes, then you don't have to explain. If no, I hope you got that question or the what we are discussing. My material thickness is 50 mm. Okay, so with 50 mm, I'll just remove this. With 50 mm, no, my cycle will be like 1 hour per inch. So 50 mm is 2 inch. So 2 hour holding time will be there. Okay, so this is very clear about the PWST. Two things are very important: the holding temperature and holding time. So, and if I'm maintaining this, I can say that the cycle has been completed. Okay. Anything else code is saying, why, if I'm doing maintaining this, have I not qualified that PWST? So Akash is saying no. So why, if I have maintained that holding time more than 2 hours, still why I need to go for another cycle? Yeah, Jagdish, prepare. Okay, so now see, be pretty clear here. There is a good learning for all of us. See, one is the post-weld heat treatment of the job. Okay, now Uday is talking now the same thing. See, one is the heat treatment of the job. The second is a simulation. Okay, now what is this? See, your job. Okay, now let us consider that the job we welded. Okay, we did the post-weld heat treatment by using this cycle. Okay, now this cycle of 2 hours, I can even achieve in 1 hour, one go, and then again 1 hour in the second cycle. That is also possible. Cumulative should be 2 hours. So in one go, I did the post-weld heat treatment of 2 hours. Okay. After that, there was requirement of radiography. I did radiography. I got repair. So I need to repair. Repair means I need to gauge and then again re-weld. So can I do welding after post-weld treatment? No. If I'm doing welding, that means my post-weld treatment has become invalid. Making sense? See, your RT after any heat treatment, the material get relaxed. So many times client will ask pre and post both. Pre we just do for our satisfaction, so that we have already checked. It should not happen that I need to repeat. Okay. The final requirement of RT will be only after your PWST has been completed. Because after that operation has been done, you will like to see whether something has opened up or not. Pre, why we do before doing post-weld treatment, we make sure that there is no repair, because if already the repair is there, which I can catch right now, then it is going to means I'm adding that PWST itself will become invalid. So there is no point. So check that if there is no problem before, then there are very rare chances that you will find problem after doing PWST, but it may happen. So you did PWST, again some repair got observed. And now you have to do post again welding. So you did welding. So you have to do post weld treatment. Now you don't have to do the entire vessel. Let us see some default defect you found at this same location. So you just locally you do post weld treatment. Local PWST can be done. But still, this material has seen the PWST cycle twice, isn't it? Guys, making sense? That this material has seen the heat treatment twice. Now there is degradation of material because of heat treatment. Okay, we always think that it will refine the course, yes, but there is degradation of material with each cycle. So if I have to do a post weld treatment from the same material, I'll take a coupon and we do the heat treatment. Okay, so now we know that at least one repair may come. So some material may see twice of PWST. So we may decide 2 times or 3 times we'll do the heat treatment of this coupon and then test. This is called simulation test coupon. So we'll simulate the heat treatment and we'll test it to ensure that properties are still meeting. Okay, so if I have already done 3, then I'm not worried, even I've done twice, I know that I have the properties after 3, so I can just justify that my heat treatment has not affected my material properties and my design is valid. Okay, so that is the reason, the test coupon will see 3 times or 4 times PWST cycle. Your job very rarely, 2 cycles or 3 cycles, but that if it is seeing, you should have a simulated test coupon where all the testing has to be done to ensure that material properties are not lost. Clear? Okay, thank you. Next question by Akash is, what is the test ring and why it is required in heat exchanger? Okay, so we are talking about test ring of for hydro testing or leakage testing, right? Good question. Let me just open any sketch. So I'll open Tema itself. Okay, let us see, this is my heat exchanger. Okay, I have to do hydro test for leakage testing for both shell side and tube side, right? Now, if I'm doing it for, let us say, shell side, okay, now consider, see this scenario, it's okay, we'll make it different also. Now, if in this case, if I'm doing the hydro in shell side, what we exactly, which portions we check? In hydro, which are the areas which are checked? Shell outer surface will not leak. No, shell area we don't check. What we check? The joints. Joint means we will be checking this. Even the long seam and surseams, you will not have any leakage. The leakage possibility is between tube sheet to tube. That is one possibility. Also, if this flange, it's a flange which is not this configuration. Okay, we'll come to that. In this case, there is no possibility of leakage from this side. Okay, this weld is butt weld, okay, or full groove weld, so leakage will not be there. So in this case, my target will be only this area, tube to tube sheet leakage. Okay, now let us change the configuration. In this configuration, you will not need a test ring. Now let us see this case. Okay, and let us consider that it's not a cover type design, it's a bonnet type design. Okay, this vessel is having a bonnet, possible, right? A decent instead of cover. Okay, now if I am doing hydro, I'll be checking this joint also, right? Here's, I have a gasket. So my area of focus will be this joint and also the leakage between tube to tube sheet. Okay. Now, if I have to check this, I need to bolt this channel side. Yes, no? Are you guys getting what I'm saying? I am doing the shell hydro. So my purpose of checking is this leak, the leak from this gasket. And the second will be the tube to tube sheet joint leak. Okay, these are the two areas of my interest. Okay, if I have to check this, you see, first of all, hydro test can be only done when I have bolted. This has to be bolted. Okay, so if I bolted this and this is a bonnet, how I'll be able to access the tube to tube sheet leakage? The joint, how I'll be able to access? Guys, can I do that? Can I access? Yes, no? I have bolted this joint. Okay, just consider the same phenomena. Just here you consider that this is a sandwich type of tube sheet and there is a flange which is welded with the shell. Okay, so in this case, okay, if I bolted this channel, then I will not be able to access the tube to tube sheet. Clear? Okay, if I don't weld it, then this path is not getting checked. The gasket, which is the most stringent, the leakage path, even more than tube to tube sheet. So how to do that? What is the solution for doing hydro? How I'll be able to do hydro? If I'm doing one, other is not getting done. What is the solution? Yeah, this is a test ring. So that is where test ring comes. So what I'll make, I'll use a dummy flange, which is not welded with the channel. Okay, so dummy flange. Now that dummy flange can be even this flange. If I plan it, that welding can be done later on, but just forget about that. That is a utilization. But basically there will be a flange required, which is a test ring flange. Okay, which will not have this welding. So I need to bolt it. Okay, so it is available for bolting. And this portion is also clearly accessible. So that is the requirement of test ring. In multiple cases, if you see the floating, it is even more critical. Okay, for floating heads, how you do, you may have two different test rings required for doing this. But now where to see that? That is also given in TEMA, that how it is done. See, this is the test. This is the testing which we are talking about, the first one. Okay, this is the test gland for packing type of heat exchanger. This is the arrangement for floating. Okay, this is the arrangement which will be required. Okay, floating also only two hydro tests, but that arrangement will be different. Jagdish. Okay, this is how we'll have to arrange. These are the taste rings. 2 taste rings will be required like this. Okay. So these are the testing. I hope that is clear, Akash. Thank you. The next question is why generally MAWP is considered as design pressure in the heat exchanger. Okay. So for heat exchanger, there is minimum thickness requirement as per TEMA. So in many cases, it may happen that your design thickness required is very less, but you are providing very high thickness because the minimum thickness required as per TEMA. So whenever you are providing high thicknesses, your MAWP will increase drastically compared to design pressure. It will be very high because you have very high thicknesses. Okay. So if now you are doing hydro test by using MAWP, your hydro test pressure also will be very high. To avoid that, we use MAWP equal to design pressure. Okay. Great. Thank you. Next question by Akash. In radiography, 85% or 90%, what does it mean actual and how radiography is done in this percentage? See, 85% means whatever the weld length is there. 100% means all the length, nothing will be left. 85% means 85% portion has to be radiographed. 90% means 90% has to be radiographed. The weld length we are talking about. Making sense, Akash? Making sense? Yeah. Total and the percentage of that. If I have 1 meter weld, I'll be testing at 850 mm of that. If 85% is up. Okay. Abhishek as posting. Okay. Thank you, Akash. Abhishek question is how we can go with 240-304 with liquid nitrogen. That's what we discussed. It is as per code, it is not possible. No, you can do impact testing. If it is passing, definitely you can go, but code limits up to minus 196. Up to that, we can easily go without any impact testing. Okay. Beyond that, with impact testing, you can go. Dual certification means you can have a material with which specification which is qualifying for 2 different specifications. Okay, like it is getting qualified for 304 also, 304L also. Okay, both the requirements are getting met, so you can provide a dual certificate. You can use it at either 304 or 304L or 316, whatever the certification has been given. No design change, just consider that material. It will give flexibility for selection. Design wise, there is no change. Okay. Yeah. Uday, you had some query? You wanted to ask something. Uday is there? Yeah. I'll unmute you. You can just, if you want to ask again. Yeah, go ahead.
So when we were talking about the radiography RT1, RT2, so we have weld categorization ABCD.
Correct.
So in RT2, we were taking A and D in one part, that is the full radiography for RT2, and B and C for the sport radiography.
Correct.
So how there's some mind thought in the code that why they have combined A and D together and B and C together.
Yeah, definitely. I'll tell you. It's a very good question, actually. Your answer lies in that location of that weld. And with same principle how we differentiate A and B.
Yeah, A and B is understood, but sir, C and
Yeah,
D.
C and D also, if you see, it's very similar. I'll tell you. Once you see the figure, you will get to know. With the different perspective now, you may have always seen the figure, but now you just try to see it again with a different perspective. Okay. Now just talk about C. C looks like which type of stresses will be governing in C?
So longitudinal.
Longitudinal. So
So
which becomes similar to B.
okay.
See, actually it is very, if I extend the lip and make a butt weld, it is as good as B, right? It's very difficult to differentiate B and C. It's very similar to B, isn't it?
And
Yes.
for the yes,
Now
sir.
coming to D. So D, if you see, what you are making, actually, you are making a weld like this. Okay, which is going in all the direction.
all the direction.
So what will be the solution? To take the stringent one.
Yes, sir.
Getting it? So we consider it as D. Any spiral or any weld which is going like in both the direction, we consider it the stringent, which is nothing but A type.
But sir, B and C are different. They looks like same, but they're
Uh,
different.
But the type of stresses will be in the same direction. Behavior will be same.
Actually, sir, my welding engineer was asking for a joint. That
Mhm.
was some Greylock connections, some nozzle Greylock. So here,
Nozzle.
Greylock, sir. It was Greylock fittings.
Mhm.
That is a special kinds of flanges nozzles.
Correct.
So there was a joint kind of C.
Mhm.
So he was asking that this is special nozzle. So I'm not aware that it is a C kind of B or B type, C or B type.
Mhm.
So I asked him, so what is the difference? What is your outcome from that?
Mhm.
So he said that if you will decide it as a B, then I will need a PTC, and if you will decide it as a C,
Mhm.
then I don't need a PTC for that joint.
Mhm.
So I was thinking that both are the circumferential joints. If
Correct.
we see, but the welding engineer was having different outcome from that.
Mhm.
So, like we have also the some different outcome from that.
Correct. See, definitely
And,
it's not exactly same. See, we'll have to study why that PTC requirement is different for these two. Okay. But if you see the behavior wise, even I feel that C will be more critical because there will be discontinuity is much more in C. Okay, compared to B. B is typically more uniform than C. Here it is a sudden change of thickness. So maybe it is providing additional support, and that is the reason slightly it is considered as a better, having less stress than D. But if you talk in terms of only pressure, then they are exactly same longitudinal stresses will be acting on that.
okay.
So
So,
see, because of see, we'll have to find the exact reason why that for B, it's a the requirement of PTC is coming and not for C. Okay. So that will be a different, maybe because the C they are considering only with nozzles, which is a small pressure. So stresses also will be less. That might be the one reason. If it is not girth, it is just a nozzle connection, then your stress intensity is much lesser than the joint B.
so the same question is like if we have the body flange
Mhm.
and shell is connected to the body flange, then it is a B joint or C joint.
That is a C joint.
That is also C joint.
Yeah. This is nothing but a flange only, no? This is a body flange.
Okay.
So this is nothing but body flange. Okay.
Okay.
And if you are making a butt weld, then you need to have a lip.
Yes, sir.
Okay. So that portion will look like exactly B, but we'll have to see why there are different PTC requirement. What is the justification for that? That I don't know.
Actually, in that time I did not ask, but I will ask to my welding engineer.
He will also not be able to explain why that B and C has different, because that See, code has given the requirement. Now, why they have given like that? That to answer that, you need to be really, really into that subject. So some may answer, some may not answer. So you can ask and check whether he is able to, because that is now mixed. It is linking design with welding. The person who is aware of both, he can answer. Because you need to have understanding of stresses also, then welding also. So if because of type of welding there is some difference, then maybe he will be able to answer. If it is linked to design, then it will be really difficult. So just ask, see if we are able to get that answer.
Okay, sir. Thank you.
Great. Himanshu is saying, why PTC required for neck to flange? Yes, that is what, it's not required. That's what you said there, right? PTC is not required. If it is a B kind, then we'll have a PTC. If it's a neck to flange C type joint, you don't require PTC. See, that may be very, on which perspective, which parameter that was selected, that we don't know. Okay. So it's difficult to say which, that will be applicable for all the cases or not. I'm not sure. Okay. Category has a role. That's what we, for post-welded treatment. Okay, let us, it may, for post-welded it is coming, then it is same, no? Why it will be different? Maybe impact might be one case, but even if for impact, the type of welding will have influence. Even for PWST also, type of welding, but here we are talking about fill penetration and butt welds. Okay, so if it's butt weld, then there is no difference. If it's a different type of weld like groove and fillet, then we know we can find the governing thickness based on that, and it will be definitely different than D. Yeah, PTC is required to test the mechanical, but that mechanical part is not for each and every welding. You don't have to take out PTC. So product test coupon, sometimes for impact testing you may have, sometimes for post welded treatment you may have. Definitely that we are checking the mechanical properties for, if you are checking for PWST. For NDT we are checking the impact testing. Okay, code nowhere suggests for entire vessel PWST. No, code is not suggesting anywhere to go for. If you can go for localized, it's good enough. Okay, Akash. Great. So to consider dual certification, 304. See, whatever is applicable, like if dual certified, you can use whatever material properties you want. If you want to use it as 304, you can use it. If you want to use it at SS304L, you can use it for designing. So whatever is the lowest material properties, use that. Higher allowable or lower? We can, for designing, like if it's both, you can do it higher because it is dual. Okay. Great. So good guys, it has a good discussion. I have covered whatever questions you have posted. Okay. So I hope this session was interesting for all of you. We'll keep the discussion happening. Okay. Thanks a lot to all of you for your participation, and see you again next time. Okay, guys. Thank you. Thank you all. Thank you. Thank you. Thank you. Bye-bye.